Okay, this is problem from section 6.3, problem number 17. I'm going to answer, part B of this problem. Find the corresponding approximation to the length of the curve by summing the length of the line segment. So as you can see that if you divide your interval into 2 sub-interval, 4 sub-interval, 8 sub-interval, then from part A you will be able to find out different diagram. Like for n equal 2, we're dividing this interval 0 to 1 into 2 sub-interval, which is from 0 to half and from half to 1. Okay, so now we would like to find out the length of this curve by summing of the length of this straight line from here to here and from here to here. So there is a formula for that. I'm going to show you the formula by using the view example here. Just completely focus on part B here in this case. So as you can see that this is the formula. The length of the first part L1 is square root of del x1 square plus del y1 square. So what is this del x k and del y k? So this is the information it's given here. Since we are using 2 sub-intervals, so k would be from 1 to 2 because n is 2. So for k equal 1, we can find out, I just use the Excel sheet here. So as you can see, from 0 to 1 and 0 to half and half to 1. So what is that here? X0 is 0 and x1 is 0.1, 0.5, x2 is 1. So this is 0, 1, 2. There are 3 points you can see in this graph. What is that? For the n equal 2, x0, x1 and x2. Now we can find out corresponding y0, y1 and y2 by plugging that x0, x1 and x2 in this function. So what I did, I just found the y by using, look at here, how did I calculate? 3 times x to the power 1/3 plus 6 times x to the power 2/3. This is the formula I'm using, and I calculated y0, y1 and y2. Based on this x values and y values, x0, x1, x2, y0, y1, y2, we can find out the del x. Now if you would like to find out the del x1, that means that's the difference between x1 minus x0, which is basically half, because x1 minus x0 is half, x2 minus x1 is again half. But what about y1, del y1? So you can find out del y1 by plugging k equal 1 here. So it's a y1 minus y0. If you look at here, what is y1? Y1 is 6.160865. Using this function, we can calculate that. Minus y0 is 0 itself. So that's the difference. Similarly, you can find out del y2 by finding y2 minus y1. Now after finding del x and del y for different k equal 1 and 2, we can find out the length of the value of L1, which is actually, if you look at this graph here, it's the length of the first part. L1 is this one, L2 is this one, and to find the curve we have to add these two lengths. So here L1 is square root of del x1 square plus del y1 square, and here you can see that this is del x1, this is del x2, this is del y1, this is del y2. So what is length 1, L1? It's square root. You can see here I'm using the formula square root of del x1 whole square plus del y1 whole square. What is L2? L2 is, by doing the same thing, it's a del x2 whole square, square root of del x2 whole square plus del y2 whole square. And if you add these two, this is the length of the first straight line. This is the length of this first straight line, and second one is the length of the second straight line. If you add these two, this is your sum of these two. That gives you the length of approximation length of the curve. So when n equal to 2, now you have to do the same thing for n equal, what is that? What is part B? If you continue, then you can do the same thing for n equal 4, but this time you are dividing this 0 to 1 into 4 different subinterval. Okay, and for that you can repeat the same thing, but instead of 0 to 2, now there will be 0 to 4. Okay, so you are dividing, you are using the second part of this graph. Where is that? This one. How many subinterval from 0 to 1? 1 point, 2 point, 3 point, 4 point, 5 points. So you are dividing this from 0 to 1 into 4 subinterval. Okay, and you can do exactly the same thing I did here. You can use the Excel sheet and you can make that formula here, and finally find the sum of each of those subinterval. That gives you the approximation length of this curve. Okay, hopefully you got it. Otherwise, just feel free to email me back. Okay.